Hello, everyone. My name is Krishna Reddy. I'm a professor of civil and environmental engineering at the University of Illinois, Chicago, USA. First of all, I want to thank Professor Nilo for inviting me to be part of this workshop to commemorate the 50th anniversary of graduate program in civil engineering at UFRGS. So I'm very happy to be part of this program. I'm going to present on geoenvironmental engineering challenges and opportunities. Before I get in there, I want to congratulate the graduate program for wonderful 50 years. And I want to particularly thank Professor Nilo, program coordinator, who has initiated this workshop. And also I want to thank all the faculty that I know, Professor Fernando, Professor Carla, Professor Lucas, very talented faculty and very friendly faculty. I also want to congratulate talented current and former graduate students. I have experience of advising some students for their PhD thesis. I served on some PhD committees, and you guys are lucky that you are part of this program. I want to thank you all who are watching this, for your attention to this program. I visited your place several times. It is always a wonderful experience, meeting you all. It's a great program and a great group of people in the program. So in my presentation, I want to just explain what is geoenvironmental engineering is, and what are the challenges, what are the opportunities, and finally, a few closing comments. And you all know what is traditional geotechnical engineering is, investigating subsurface conditions, designing foundations, designing earthworks, investigating landmass problems. These are all very important topics, and the role of geotechnical engineers is very essential for infrastructure development. However, if you look at what is happening over the years, this graph shows, the development, human development index on x-axis and ecological footprint on the y-axis. All the development that we are talking about has come out with a lot of ecological and environmental damage. We didn't really care about, depletion of natural resources, increased waste generation, increased pollution, increased greenhouse gas emissions, and climate change, and we ignored life cycle sustainability. Now we are realizing that this is not the way to go forward. We should be thinking, differently. Particularly, we should be paying attention to any kind of environmental issues that we're going to bring in while developing the infrastructure. So this is where a lot of initiatives came up. In 1976, in the U.S., Congress passed a new law called RCRA, Resource Conservation and Recovery Act, that basically addressed the issues of disposal of newly generated hazardous and non-hazardous waste, and required the engineered containment facilities, landfills. In 1980, U.S. Congress passed a Comprehensive Environmental Response Compensation and Liability Act, called known as CERCLA or Superfund, to clean up contaminated sites. So when these laws were passed, geotechnical engineers' knowledge of earth materials and groundwater became vital in order to design containment facilities to manage the waste, and also to investigate, design, and clean up contaminated sites. So the US EPA developed regulations, technical guidance documents. Now they are used worldwide, and many geotechnical engineers have contributed to these efforts. And as a result, geoenvironmental engineering evolved. And what is geoenvironmental engineering, right? So basically, the geoenvironmental engineering is the design and application of engineering solutions for challenges related to non-hazardous, hazardous waste management, characterization and mitigation of contaminated sites, enhanced environmental sustainability and resiliency. But all these solutions require multidisciplinary technical approach that includes soil and rock mechanics, hydrology and hydrogeology, geochemistry and biochemistry, contaminant transport and transformation, human and ecological health risks. So This is what is geoenvironmental engineering is. And it is, as I mentioned, it's a multidisciplinary technical approach. I wrote an article in 2014 on how the geoenvironmental engineering has evolved. And this geoenvironmental engineering is very essential for environmental protection and sustainability. So we should be looking for infrastructure development. At the same time, we should be also looking for environmental protection and sustainability. So when we teach in the universities, we should be teaching geotechnical engineering courses. We should be also teaching geoenvironmental engineering courses so that we are developing the infrastructure at the same time trying to protect the environment. Now there are two terms that are used to express this field. One is environmental geotechnics. Other one is geoenvironmental engineering. Environmental geotechnics is kind of narrow in focus. It's more on applying the traditional geotechnical engineering to geoenvironmental problems such as slope stability, settlement, so forth. Geoenvironmental engineering is, on the other hand, it's a broad field where you apply multidisciplinary background to solve geoenvironmental problems. So it's much broader than environmental geotechnics or geotechnology. So I really prefer the use of word geoenvironmental engineering rather than environmental geotechnics, because we advance so much in this field. Now, in geoenvironmental engineering, if you work, there are a lot of interesting challenges and problems to address. And one of the problems is the waste issues. Municipal solid waste, all the garbage that we dispose of, every day. That is, still in a lot of countries, they send it to dump sites. In US, of course, we have landfills, but in all the other countries, I think in Brazil, 60% of the waste goes to dump sites. In other countries, in India, other places that the statistics are available, this waste goes to dump sites, and dump sites create a lot of issues. And then a lot of industries, we create hazardous waste, and that is also not properly handled. And as a result, the soil and groundwater is being contaminated. And nuclear waste is considered as a clean energy because it does not emit any greenhouse gases. But on the other hand, it creates this radioactive waste, and that needs to be properly managed. You need to have containment systems, otherwise the exposure issues are very severe. Mine waste, in Brazil, the problems with the mine waste. If you don't handle this properly, there are physical threats as well as environmental threats associated with one. So you may be talking about any type of mine, iron mines or copper mines or like gold mines. All these mines have these kind of mine tailing issues that needs to be dealt with. Coal mines, I visited a coal mine in India. There are a lot of issues on at the coal mines in terms of the environmental aspects. And even the coal, when you burn in power plants, you create this coal ash. And that is generally, disposed of in unlined pits, and contamination, infiltrates into the ground, and groundwater is contaminated, or you have some discharges into the surface water. So this is a big issue. And in addition to the waste, we have a lot of industrial byproducts that are generated. For example, steel slag, carbide lime, bauxite residue, fly ash, and granular blast furnace slag, or many other industrial byproducts. And right now, they are being stockpiled or sent to landfills. So we need how do we address these things, because these have to be addressed, otherwise we may have several environmental issues. And in addition to the waste and byproducts, we have a problem with the polluted land. So in the past, we didn't care about how we handle our waste, and also there are accidental spills. So because of that, a lot of sites have been contaminated, and you have soils and groundwater with this nasty contaminants that needs to be addressed. Now recently, everybody aware of greenhouse gas emissions and climate change and climate impacts, and these are threatening how we handle the waste containment systems or even geotechnical systems. So these needs to be looked into. Greenhouse gas emissions are considered almost like air emissions, air pollutants. So that needs to be addressed also. In the broader context, sustainable development is essential because we have population growth and climate change is happening. As a result of these, we have series of issues: greenhouse gases, pollution, waste, resource depletion, socio-economic issues, and the sustainability development is in general is a threat. So there is a need for addressing the sustainable development through triple bottom line aspects, and not only the geoenvironmental issues, but also geotechnical issues. But in general, all engineering issues have to be looked at through the sustainability. So this is another challenge that needs to be addressed. So just to recap the challenges that I mentioned, we have to manage the waste and industrial byproducts that we are generating. How do you clean up and reuse polluted sites? How do we mitigate greenhouse gases and address climate change impacts? It's called resiliency. How do we achieve enhanced environmental sustainability and resiliency? So these are kind of challenges that I see that needs to be addressed urgently and going forward. Now, when you say challenges, that really kind of gives headache to everyone. But on the other hand, if you are a researcher, you look at these challenges as the opportunities for doing more research. So this is kind of exciting aspect to the researchers. Now, when dealing with waste and byproducts, we should be looking at this, the waste management issue at a broader level. So this is the hierarchy that has been proposed, for a long time. So try to prevent and then go down the ladder. But this is really not working, because if you focus on certain things at a high level, and if you're not able to achieve that one, then everything falls apart. So recently, instead of hierarchy, people are suggesting integrated waste management approach. So we should be looking at all those things simultaneously rather than hierarchically. So materials and recycling, that's where we as a geotechnical engineer, geoenvironmental engineers can play a major role. And also landfills, we geotechnical and geoenvironmental engineers can play a major role related to landfills. So in terms of recycling of materials, there are many industrial products, waste products that I mentioned, and they all have potential to reuse. But the problem is, the applications are not looked at completely to be able to characterize and use it in the field. So a lot of times people do characterization in the lab, but they don't really do the field scale demonstration, and then trying to develop the specifications, identifying what are the constraints in applying the field, and also looking at the sustainability overall of using these materials. So we really need more thorough investigations leading up from characterization all the way to into the applications. So very few recycled materials have actually been successfully demonstrated to be used in the actual field applications. So we have a lot of research opportunities in terms of characterization of recycled and byproduct materials. And we should be not only looking at the geotechnical aspects, mechanical aspects, we should be looking at environmental and durability aspects are very important. And we need to really develop and demonstrate the field applications and develop that performance data so that people are confident about using these materials in actual field applications. And we should be aiming at developing the standards and design guidelines so that more extensive uses can be achieved in the field. On the landfill side, this is really bothers me a lot, because we still have these dump sites. We know that dump sites pose a lot of problems. I understand in Brazil that more than 60% of the waste right now is going to the dump sites, and in India, same situation. We should not be allowing these kind of situations, because this is going to lead to more problems into the future. So should not allow no open dumps. And in US, we have engineered landfills and impoundments to address these waste issues. We have landfills, we have surface impoundments, and we have good guidance on how you design these landfills. You have bottom liner system, side liner system, leachate collection system, and final cover systems. So this is well established in US. We have all the design guidance, and we design it and we build it and we're operating them. So I'm just saying that we have resources to design these landfill liners. So it's well established, in terms of research and practice. And in US, we still are doing some research on landfills to improve, even these landfills that have been proven to be performing quite well. So we are looking at, how to degrade the waste a little bit faster, leachate treatment issues, fugitive gas emission issues, and achieving the sustainability through mining and other issues. So this is what is going on in the US. And as I said, bioreactor landfills are being researched so that, we can make these conventional landfills more efficient in terms of the waste degradation, gas collection, leachate management. And then finally, when all the organics gets degraded, you're thinking about landfill mining and, and recovery of resources. And the same thing, if you have a hazardous waste, we have hazardous waste landfill guidelines, we can follow those. And then, there are landfills that have been designed like this. But my problem is, in terms of the research opportunities elsewhere, you should be thinking whether US practices are applicable in your country or not, okay? So what I see is people just try to follow what is being done in the US and not able to do those things. And as a result, we are not properly managing the waste and causing all kinds of problems. So we should be looking at it, sustainable and effective containment systems, landfills and impoundments. We need to be thinking about creating new and innovative indigenous systems. So look at what is possible in your country. So we can come up with alternative liners, leachate collection and removal systems, cover systems, leachate and gas management systems. So, that fits into the local conditions. So use of local materials, use of local construction and monitoring techniques, and life cycle thinking. What are we going to use the site at the end? Sustainability and resiliency. These are the issues that we need to be thinking about it. Don't have to follow what is done in the US. So you should be looking at locally and what is really possible. Because let's say in the landfill liners you need geomembranes. These are the geomembranes available locally, or you need 10 to the power -7 clay liners. So is that material available locally? If not, what can we do to get alternative containment systems that can perform as well or even better than the landfills that we use in the US. So also we need to develop standards and design guidelines for these things. At any cost, we should be avoiding the dumps. They are only problematic going into the future. And as I mentioned, in addition to this managing the waste, we should be looking at the land pollution. And we didn't have regulations. Even now, a lot of countries have regulations, but there is no enforcement. So as a result, these wastes are being dumped everywhere. And then you have land and contamination, soil and groundwater is being contaminated. And that is really a problem. Even dump sites, everything that you dump there eventually leaches into the soil, and surrounding soil and groundwater is going to be impacted by this one. So what is the issue? Because this contaminants that leach out into the soil and groundwater, they are very toxic. Most of them are carcinogenic. So we need to really worry about health impacts on humans and also, adverse impacts on the surrounding ecology, So in the past, we didn't have any laws and regulations and people were disposing all these things. But in the US, we have strict laws now, these things are not allowed. And what we are trying to do is, develop that contaminated site into usable purpose, as I shown here. So for this one, if you have a contaminated site, there is a logical procedure by which we can clean up the contaminated site. So in this one, site characterization is very important. Like, how we do the geotechnical investigations, kind of the same way, but a little bit more additional information on pollution data. And risk assessment is one thing that is not familiar with the geotechnical engineer. So in geoenvironmental engineering, we deal with that one. And then we have a lot of different remedial alternatives that we can follow. Let's say if you have an existing site, you don't want contamination to spread more than where it is. So we have vertical barrier system and cover systems that we can put it in and close the sites. And if you have a soil or groundwater that is contaminated, we have developed different soil and groundwater remediation technologies. And these are being used extensively in the US to clean up the contaminated sites. So these are, even though there are many technologies, but these are the sites that are actually being used in the field. There is a lot of performance data for these things. So the research is more into understanding the fundamentals and developing these technologies. So, in US, a lot of work is going on these things, and we are making good progress on this one. But elsewhere, there is a lot of need for research. And one of the things that you should be looking for in the research opportunities is, we need expedited, inexpensive, and accurate site characterization methods. Okay, we cannot spend a lot of money. So the methods to detect the contamination is one of the things that should be looking at it. And again, I ask this question because in the US we do certain things, but our conditions are different than the conditions in different countries. So you need to look at local socio-economic issues versus environmental risk issues, and then that's when you decide the strategies on how you remediate it and to what extent you need to remediate. And you need to develop the innovative green remediation technologies. As I mentioned, we have a lot of different technologies that are developed in the US. Can we use those things? Because some of the things may not be usable in the country where you are. Local materials, local labor, local equipment is different. So we need to be thinking about differently, challenging geological and hydrogeological conditions. So each location is different in terms of the soils and groundwater. And it's we need to tailor the technologies to meet the local conditions. And there are difficult contaminants. Local contaminants could be different, so we need to tailor the technologies based on the contaminants that exist. And also, we should be thinking about when we clean up the site, what are we going to use it for? So ultimately, what we want to do is we want to address the pollution. At the same time, we want to put the site into productive use. And how do we do this one in a green way, sustainable way, resilient way? So these are the lot of interesting research opportunities for researchers going forward. As I said, greenhouse gases, climate impacts are becoming more and more, and there's a lot of research opportunities in this one. So again, when you have greenhouse gases, when you have climate impacts such as flooding, coastal, sea level rise, and all those things. So any sites, any waste facilities or landfills or dump sites, they're going to be severely affected. So we are looking at, geoenvironmental engineering solutions. How do we sequester the carbon? How do we reduce the CO2 from atmosphere? So using the phytotechnologies that can be accomplished. If not, underground storage of CO2. There's a lot of geotechnical and geoenvironmental engineering issues involved in this one. And if we cannot fix the problem right away, we need to be making sure that existing contaminated sites along these affected areas are going to be protected. So now there are efforts to prepare these sites so that any effects that happen are not going to be impacting the performance, not causing the pollution problems more with the flooding or sea level rise and other things. So there is a lot of emphasis on resilient design. So if something happens, the flooding or storm, whatever it happens, so you may be compromising it, the performance of it, but not to the extent that it loses the complete performance, but hopefully it can recover and even perform better. So this is basically resilient design. So we should be thinking about resilient design in areas where we expect these climate impacts or any other extreme events that we look at it. As I said, in the long run, we should be looking at climate mitigation, basically reducing the greenhouse gases, and we should be looking at socio-economic issues in a broader way. So this can be accomplished by so-called triple bottom line aspects, environmental, economic, and social aspects, and also that we don't pay attention is the life cycle stages. So we need to consider all these things, and we should be looking at life cycle sustainability assessment framework and looking at a sustainability to achieve these environmental friendly, economic viable, and socially acceptable solutions. In general, geotechnical and geoenvironmental. I'm showing you an example of geotechnical here because if you have these 4 different types of retaining walls that are possible to use it, which one is more sustainable? So we should be looking at the sustainability assessment and making the final decision on which one to go with. So same thing in geoenvironmental engineering, remediation technologies, waste containment technologies, all these things can be optimized. In a broader sense, even when you look at integrated waste management, that should be made sustainable considering these environmental, economic, and social aspects, because every country is different. And as I mentioned, now in addition to sustainability, we should be looking at resiliency also. So going forward, we should be looking at both sustainability and resiliency, and we should be optimizing the designs based on these considerations. So a lot of people are now going towards the nature-based solutions because they have potential to be sustainable and resilient. And there are a lot of advantages for these things. So less energy, you conserve natural resources, reduce the waste, adaptable, resilient, cost-effective, and these are generally socially acceptable. On the other hand, you need a multidisciplinary background, and you don't have methods that are standard, and you don't have tools that are standard, and we don't have a lot of experience dealing with these kind of solutions. There is uncertainty in the long-term reliability issues, and there are a lot of fundamental issues that needs to be addressed also. But this is the area that needs a lot of attention going into the future. And I wanted to give you some simple example here. What do you mean by nature-based solutions? But for example, if we have a coastal problem, it's a sea level rise or surge issues, this is the standard way we do it. We just construct a seawall, right? That's the standard practice. But now, instead of that, we are looking at these floodable parks or wetlands. So the whole approach is kind of different, because this wall, you don't know, how what the surge is going into the future, if this is adequate or not. Also, resources that we use, in the conventional systems are not acceptable anymore. So going into the green systems like this one is becoming more and more popular. So we should be always looking at a nature-based solution. So going forward, we should be looking at sustainable and resilient infrastructure, both from the geotechnical point of view and also geoenvironmental engineering point of view. So in closing, I want to reiterate that population is growing, and when economy grows and human activity increases, infrastructure is being developed, we're going to have a lot of adverse environmental effects, and we have seen that one. So going into the future, we should try to avoid these things. So to avoid all these environmental issues, we should be looking at a multidisciplinary approach, in terms of particularly beneficial use of waste materials and industrial byproducts, waste containment systems like landfills, site remediation technologies, and in general, sustainable and resilient development that we should be looking at. All these things requires a fundamental research that can be done in the universities. But at the end, this fundamental research should lead to practical solutions. We are looking at innovative, practical, sustainable, and resilient solutions. So research should be taken into the field and should be demonstrated applications in the field. So from my point of view, geoenvironmental problems vary spatially. Problems that we have in the US are different than problems in Brazil. Problems in India are different. So we should be looking at culture, climate, economy, lifestyles, the geology, all these things to solve the local problems sustainably using the local available resources. So these require not the standard solutions, so innovative solutions, locally, adaptable solutions. So there are many opportunities for research, and create new solutions to solve the problems. So that is not happening right now because we're trying to copy some solutions from somewhere else, and it's not being practical to use it. As I said, landfills. We're not having landfills because in other countries because it's hard to design and build the same way that US does. Because you don't have local resources and local labor. And the scope of geoenvironmental engineering is great, but it's not being recognized by the geotechnical engineers, geotechnical researchers, because the geotechnical engineering and geoenvironmental engineering will go together, and there is a lot of scope for this one. And I see, few universities are doing better, but, I guess I saw your university is doing great. Professor Carla and Professor Nilo are doing a lot of work in this field. But, we need to have more educational research and practice endeavors, because, there are so many problems that need real research and real solutions. So, this is very important, and we should be thinking big, thinking about contributing towards the UN Sustainability Development Goals, contributing to the humanity, contributing to the planet. So we should get out of our silos, think a little bit, broader, rather than, narrow way we have been, working on this one. So again, I want to thank all organizers for giving me the opportunity to say a few words. And if you have any questions, feel free to send me email or connect me on Twitter, Facebook, and LinkedIn. You have my lab websites where you can find more information about our research. Thank you all. And, I'm not sure if how the questions can be handled, but I will be happy to answer any questions that you have, on any topic that I covered here. So thank you so much, and thanks a lot again to Professor Nilo and all the faculty at UFRGS, and also all the students. And thank you so much for this opportunity.